Okay, let's talk about the roof models that you're going to be building. So you've got the two worksheets that you drew the roof plan, the eaves, the edges, the ridge, and the valleys, and you've got these drawn. Um, you've got to make a pattern to create a 3D model of the roof. And you cannot just take your roof plan and cut it out and fold it up because it'll be too small. Because we're taking a 2D representation, giving it depth to make it a 3D object. So and it's just basic math. You just set up a ratio using your roof slope to calculate the height and the hypotenuse. It's really that simple. So I've put a cutting plane line through here, and this is what you have to imagine you're doing, is you're going to turn your roof up on the edge. So you're looking at it from the end, and you're going to see a triangle. You'll see an isosceles triangle, and we're going to cut that in half at the ridge, and that will give you a right triangle. Okay. Now the roof slope is always done as however many units to 12. So it's rise over run. Run is always 12 when you're annotating or dimensioning it. And so I've drawn out a triangle here, a rise of 6, a run of 12. That gives me a hypotenuse or a slope distance of 13.4. Okay. So if you take an architect scale, and I'm going from memory here because I don't have the actual worksheet and a scale handy with me right now. I want to say it's like 14 feet across here. I don't remember that, but if you take an architect scale at 1/8 of an inch, it should be somewhere around there. But you measure it and make sure. Okay. So what I do is I set up a ratio, my roof slope, 6 to 12, to x over 14, whatever the distance is from the ridge out to the edge of the roof. Okay. In this case, if it were 14 feet, the rise would be 7 feet. Okay. And so I can take that, and you can certainly draw this out. You can do the math now because I know like this would be 7, this would be 14. I can use Pythagorean's theorem to calculate the distance of the hypotenuse. So it would be, 7 squared times 12 squared, or plus 12. Excuse me. 7 squared plus 14 squared, and then take the square root of that. That will give you the length of the hypotenuse. And so what that would be, let me turn off my tracking, would be that line right there. That's what I'm calling the slope distance. Okay, and in this particular case is 1.95. So if I were to come back to my pattern here, and I'm going to do an offset of 1.95. Let me change that to green, so it'll be something different. And I'll do an extend. Thought I was going to do an extend. Okay, and then now we're to continue this out, and it would be the same here. Okay, so from the ridge out to this green line, that's half of my pattern for my new roof. Okay, so you do the same over here. You'd measure out whatever it comes out to be when you've done your calculation, and then draw that in. The length of the roof will still be the same because that's not changing. It's just the eaves. And then when you cut it out and you fold it up, you pull the ridge up, then the edges of the eaves here will line up on top of the edge of your drawing. Okay, so that gives you the overall pattern. But now to get the height, the actual height of the roof above the wall, I've done it in yellow because I want to take the overhang portion out. Because let's look at a photo. Because these little gable ends here represent the walls, and the walls don't go all the way out to the edge of the roof. Okay, so they stop short of that. So the height of those gable pieces will be different. So I come back, I go back to my formula here, and instead of 14, I would use the distance from the ridge, from the ridge to the actual wall overhang, which in this case is 1.5 inches. Okay, and I don't have to calculate the slope distance. All I need to know is the height right here. And this one, I've already done it and drawn it. And so if I close that in and then mirror that, that gives me the pattern that I would cut out for my gable end. That would go right here. And if you notice, looking at the models in the lab or at the photos here, I put little tabs, an additional, 1/4 of an inch or so of material, so that I can fold it over and give me something to tape with. And when it comes time to folding these things, if you'll take like your architect scale and set it down and then lay your cardstock on top of it and kind of push down on top of the scale, it gives you a nice clean edge that you can use to bend your paper over. Just a little tip there to help you. Okay, now this part of the roof, and if you notice, I made the main roof one piece, so it just goes straight through. And then the garage portion here, this little wing that steps off, is a separate piece that just gets glued on top of it. Okay, but you have to calculate a different slope distance because the span of this roof is different. So you have to calculate again using your formula, 612 to whatever the run is from ridge to eave, and you come up with a new slope distance. And then you would draw that out. Once again, the length stays the same. It's anything that would be sloping or going up that changes. So you do that calculation, and let me go to a different color here. And like I said, this will be the same. So let me copy this out. What's going to change is the slope distance here. And let me just measure it to see what it is. So right now we're at 1.55. So I'm going to say I did the calculation, and I don't know what it comes out to because I'm not calculating it. I'm just going to make something up. It's not 1.8, but I'm going to use 1.8 just as an example. Okay. And then this distance here will be the same, 1.5. And so there's your pattern with your slope distance that you calculated. And then the valley portion right here it's just whatever it ends up being. So you just connect those two endpoints. That gives you your valley. Now in a roof plan view, most of the time valleys and hips are at a 45-degree angle. In your pattern, it will not be until you cut it out and fold it up and tape it together. And then when you look down on it, it will appear to be at a 45-degree angle. Okay, so now for the hip roof, let me take some of this stuff out here. Okay, so for our hip roof, let me turn this back up. 45. So you're going to have a hip here, a hip drawn down here, and a hip drawn here, and a valley coming up. So let's go back to our photos. Okay, so you'll create one pattern for this. Now this one we're doing that at 812 slope. So your main roof will be one pattern, and you can calculate it and draw it out as a rectangle. Okay, and then you need to know the point where the actual ridge starts. So you come back to your plan right here that you've sketched, and you dimension from that point to this point. So in this case, that's 1.75 inches. So you come back to your pattern, and from the outside edge of your rectangle, you measure in the 1.75 inches, because you're doing it up here, measure in 1.75 inches and put your mark there for where the hip and the ridge intersection is. And then you would draw this angle at whatever it is that joins those two together. Okay. So you do that, and it's going to be mirrored on the opposite side. So this main piece will be kind of like a butterfly, if you will. Okay. The hips, this portion down here, you can pretty much take this one. No, let me back up. So you can take the same measurements you used for this, the main body. The slope distance from an eave to the ridge is the same as from the eave here to the point. The width of it across here, the eave of the roof, will be the same distance measured off of the sketch. And you just find the midpoint of it and draw a perpendicular line, whatever the slope distance is, and then connect those 2 points to create an isosceles triangle. That gives you this end piece. Okay. Now this end of the roof is same as before. You've got to do the calculations over again because the width of the roof is different. And then you can take this piece that you drew and lay it on top of this piece and trace it so that you get that corner right there. And then these two pieces of the roof will be identical. And then you calculate again for the hip that goes on that end. And let me go back and give you a bottom. Here's a bottom view of the hip. So you can see the main body of the roof here is one piece, but it's a butterfly shape when it's laid out flat. I've got one piece for the triangle here. And then I did this end of the hip, and the main body of this roof is one piece. Okay. And then I cut some triangular stiffeners to go on the inside. That just keeps the roof at the proper height and shape. And so you can see there how it goes. Okay. So that should help you with preparing these roof models.